make an island, but he could raise our little sand. Was our blue child. Oh, there was our blue child, baby.
Okay, hi there. Today, for pre-calculus, I'm going to be covering long and synthetic division and graphing polynomials. So synthetic division is the easier one compared to long division. And for this is like your typical kind of problem where, I'm taking this 4x to the third minus 7x squared minus 11x plus 5 and dividing it by x plus 5. So in order for me to start that, I'm going to take the 5 over here. And it's actually going to be the opposite sign if it's set up like that. The reason why is because we're checking to see is x equal 5 a solution. And remember back if I gave you, x plus 5 in parentheses, and check to see if it was a solution, you'd go x plus 5 equals 0. And therefore, when you solved it, you got x equals negative 5. So therefore, you're checking to see if this, this curve, wherever it is, it's going to hit negative 5 on the graph, okay? So that's what we're doing. So I'm going to take negative 5, it's the opposite of the one in the parentheses, and then I'm using the coefficients here, just the coefficients, the 4, the negative 7, the negative 11, and the 5. And 4, negative 7, 11, and 5. And I'm going to draw a line down here, and that's how I start. And then the first thing I do is I bring down that 4, okay? So you bring the first one down, and then I'm going to multiply negative 5 times 4, and I'm going to put the answer below the 7, okay? So that's negative 20, and then I add straight down, okay? Negative 7 plus 20 is negative 27, and then I'm going to multiply, and I'm going to take the negative 27 times the negative 5, and I get 135. And that should be a negative 11, because it's negative up here. And then I'm adding straight down. Negative 11 plus 135 is 124. And then I'm taking negative 5 times 124, and I'm getting negative 620. And I add straight down, and I get negative 615. This is the remainder, okay? If you got 0 as a remainder, that meant that went in evenly, okay? So anyway, that's what that is. Now, that's not the way you should write your answer. The way you should write your answer is, I start up here with the x to the third, so I'm going to subtract 1 from that and go to x squared here. These are the coefficients. All right, so this is 4x squared minus 27x plus 124, and then it's plus, and I'm keeping that x minus 5 over here, okay, and that's going to always go in the bottom of a fraction, of the fraction, and in the top of the fraction goes the remainder, negative 615, and that's the correct way to write your answer, okay, so please write it like that. Just saying the remainder is negative 615 isn't quite enough. All right, so anyway, that's how you do synthetic division. And we're going to do a couple more, all right? This one's a good one right here. We're going to do this one together. I'm going to put negative 2 here. Once again, it'll be the opposite sign of what you see there for the divisor. Put a line down here. Now, what's interesting about this one is that notice how one of the things you want to check is make sure you've got all the exponents covered. Now, there's no x squared here. So I got a 5x cubed, but I have no x squared. So I have to put a 0 in there, and it's crucial. Otherwise, you'll totally get the wrong answer every time. All right, but I have an x, and I have a regular number, so all the rest of those are covered, all right? So that was for 0x squared, okay? So that was 2. So that's where the 0 came from. All right, now I bring down the 5, and I multiply and add, multiply and add, multiply and add. Negative 2 times 5 is negative 10, and add. Gives me negative 10. Multiply. Negative 2 times negative 10 is positive 20. Add straight down, I get 14. Multiply again. Negative 2 times 14 is negative 28. And then I add straight down and I get negative 20 is my remainder. So I'm going to write my answer here. I'm going to go 5. Let's see, I started out with x to the third. So this one's going to be 5x to the second minus 10x plus 14 plus, what was it, x plus 2 is the denominator. And my negative 20 goes there. And that's the answer. Okay? So, that's that one. Now, suppose in the next one we do long division. Alright, so this one's a little tougher. I'm going to start out by just setting this up. I'm going to go 4x plus 5 over here, and I'm setting up my division. Inside I got 4x to the third minus 7x squared minus 11x plus 5. Okay, now to start it's division, alright? So, believe it or not, it's the same steps that you did when you learned long division, and hopefully you learned long division. So when you learned how to do long division like this, the first thing you did was go 8 into 25. What's 25 divided by 8? And that's like 3, right? So if I go 3, and then I multiply 3 times 8, you get 24. And then you subtract 24 from 25 and get negative 1. Positive 1, sorry. And then you bring down the 2, and you get 12. And now you divide again. 12 into 8 is 1, and then you multiply 1 times 8, and you get 8, and subtract, and then you get 4, bring down the 0, divide once again, and you get 5, so the answer is 315. It's the same steps that we're doing, it's just we're doing them with polynomials over here. So the first thing I'm going to do is divide, okay? Now I'm going to ignore the plus 5 for a minute and go 4x to the third divided by 4x, okay? And when I divide those, I get x squared. Lousy 2. So if I put the x squared up here, and then I multiply it, now you're going to multiply x squared. Now the plus 5 comes into play, so I'm multiplying it times 4x plus 5. And when I do that, I get 4x cubed plus 5x squared. And that I'm going to put underneath here. Now you got to subtract, and you got to subtract that 5x also. So there's two ways you could do it. You can either subtract both of them, or you can make them both negative and change that to a positive. It's probably easier to do what I just did of change both the signs. It's really easy to not subtract the second one. So I get negative 12x squared, and now I divide again. So I'm going to take negative 12x squared, divide by 4x, and I get negative 3x. Remember, you subtract the exponents when you divide. So now I got negative 3x. So now I'm taking negative 3x and I'm multiplying it times 4x plus 5. Negative 3x times 4x plus 5. And when I do that out, I get negative 12x squared plus negative 15x. Get 12x squared. Change colors here. Or plus negative 15x, either way. So the other thing I'm going to do is I need to bring down that minus 11x, okay? And now I'm going to subtract both of these, which means I want to change all the signs around here. So I'm going to make those pluses, and now add straight down. And I get negative 11 plus 15 is 4x. I'm going to bring down the plus 5. And this was kind of nice because that goes into it once. And I get 4x plus 5 when I multiply the 1 times the 5, 4x plus 5. Put it down underneath, subtract, you get 0, no remainder, which means that my answer is this. After you're done dividing, it's x squared minus 3x plus 1, which I just got off the top up here. Okay? And that's how you do the long division. All right. Next, we got the remainder factor theorem. If the polynomial f of x is divided by x minus k, the remainder is r equals f of k. And I'm going to show you how to use that too, but I figured I'd write it down for you so you can see it once. Okay, so we're going to use the remainder theorem to evaluate at x equals -2. So notice I didn't change the sign on that one because they said x equals. It's not x minus 2 in parentheses. So I'm using the same number, not changing the sign. And then I'm going to use synthetic division to evaluate it. All right, and the idea is I want to find out what the remainder is. That's really the big thing. Okay, so I'm going to bring down the 3, and that's how we start, just like we did before, and then multiply and add, multiply and add. So I'm going to multiply -2 times 3 is -6. Add straight down, I get 2. 2 times -2 is -4. Add straight down, I get 1. Multiply again, -2 times 1 is -2. And then add straight down, and I get -9. Okay, so my remainder is -9, which means that if I'm writing this as f of -2 equals -9. Now, what does that mean? What that means is -2, -9 is a point on the graph of the function, and we can check it by plugging it in. If they ever ask you to prove it, the easiest way to do it is simply to plug in, the x value into the original equation, which in this case is the -3x cubed plus 8x squared. I just took that same equation up here, plus 5x, this one right here, and I plugged the -2 in, all right, and I got this down here, and then I just simplified it. Simplified, and I got -9, and there's your proof that it's a point on there, and that's what the remainder theorem is showing. Okay. All right. So I showed you that. Another one. Use the remainder theorem to evaluate f of -3. Okay, so I'm going to take -3 over here. I'm going to use my coefficients here. I got a 4. I got no x squared. Okay, so I'm going to use the remainder factor theorem to evaluate f of x equals 4x cubed minus 13x plus 10. So I'm going to do synthetic division. It's important to notice that there's no x squared up here, so I'm going to put a 0 in there for that. Okay, so I got 4, 0, -13, and 10. It's important, super important to put that 0 in there if you're missing any of the exponents going down. Bring down the 4, start multiplying. 3 times -4 is -12, and then add straight down. I get -12. -12 times 3 is +36. Add straight down, I get 23. And if I multiply times -3, I get -69, which means -59 is my remainder. And that is what f of -3 is going to be. So once again, that means that, -3, -59 is going to be a point on that curve, and you can always go check it that way, okay? All right, next one, you try this one. Try f of -2 into that polynomial, nice big one for you, 2x to the 5th minus 3x to the 4th plus 4x cubed minus 5x squared plus 6x minus 2. All right, so plug that in and see what you get and evaluate it at -2. All right, next. Graphing polynomials with a degree 3 or 4 using the leading coefficient test. So the leading coefficient will be that there's a 1 in front of that x to the 3rd, which means the end behavior of this will be down and up. And so remember, if it's x to the third, if it was negative x to the third, it would have been the opposite, which would have been up, down. If it was x to the second or any other even one, it would be up and up. If it was negative x to the second or negative x to the fourth or negative x to the sixth, it would be down, down. Okay, so it's important that you remember those four. Definitely write them down. And so back to this. So I'm going to factor and see if I can solve this. So I can pull an x out of both of those, which will leave me with x squared minus 25. This equals 0, which means either x equals 0 or x squared minus 25 equals 0. And if I add 25 to both sides, I get x squared equals 25, and take the square root of both sides, get x equals plus or minus 5. So I got three zeros there. I got 0 and plus or minus 5. And if I plugged in 0 for x, I get 0 cubed minus 25 times 0 would also give me 0. All right, so what does my graph look like? That's the question here. So if I make a quick graph, it's not going to be, it's going to be one of these sketch a graph kind of things. I know it's going to cross the x-axis at 0. It's also going to cross it at 5, and it's also going to cross it at negative 5. And we said that it's going to have end behavior of down and up. All right, which means it's going through all of those because there's none that repeat. There's no x squared or x plus 5 to the second power, because then it wouldn't go through the point. It would hit it like with a parabola. Okay, so anyway, all right, so that's what that graph looks like. All right, I got the x-intercept, the y-intercept. All right, next one. This one. So if I go do the same setup here, I got x, I got y, put in 0 here, 0 for x, 0 for y. Well, if I plug in 0 for x, I get 0. Put that in parentheses. So that's all 0, right? That's a nice easy one. The other one, I'm going to start factoring. If it equals 0, then I got, pull out an x, I get x squared minus 12x plus 36. Well, that's pretty easy, huh? What multiplies to 36 and adds up to negative 12? That would be x minus 6 and x minus 6, which means I get two zeros. X equals 0 and x equals 6. If you want x minus 6 equals 0, you'd solve it and get x equals 6, okay? Now, this has two of them, all right? This has multiplicity of 2 is what that's called. And that's just because there's two of them right there, okay? Which means it's going to be more parabola-like with that one when I graph it, okay? Let me put in my zeros here. I got 0 and 6. All right, so make my graph. So over here is 6, and here's 0. Those are my 2 points where where it's going to cross the x-axis. Now, end behavior. This is x to the third, which means my end behavior is going to be down, up, just like the last one. The difference with this is it's down and up. Now, it's not actually going to go through that one because there's got a multiplicity of 2. It's going to be like a parabola where it comes down, that curve is going to come down and just touch it and not go through it, okay? This one goes up and then it goes like that, okay? So you can see that it doesn't go through the point 6, okay? Just touches it. All right, and that's my graph. That's it, all right? Next one. So this one, if I was to multiply that out, I'd get x squared, and x squared would give me x to the fourth, okay? If I took this 2, multiply that out, you get x squared. This one will be an x squared, and then I'll multiply them together and you get x to the fourth. My leading coefficient will be a 1/2. Okay, so this means my end behavior is going to be, up and up. Okay, A is positive, and the exponent's even. Okay, all right. So let me plug in some zeros here. If I plug in 0, I get 0 plus 1 squared times 0 minus 3 squared. So that's 1 squared is 1. Negative 3 squared is positive 9 times 1/2 is 9/2, or 4.5. Okay. Now the nice thing about this is I don't have to factor it. It's already all factored, which means either x plus 1 equals 0 or x minus 3 equals 0. I'll get my two answers, x equals -1, x equals 3. Now remember, these both have multiplicities of 2. Which means they're going to be, a parabola-like. They're going to hit the point, not go through it. Yeah, all right, so let's see. I got 3 and -1. I'm going to go over here, make my quick graph. Oh, I already started this one. That's from the earlier. All right, so those bad line. Okay. -1 and 3. And we said the end behavior was up and up. So start here. Okay, now it doesn't actually go through either point because both of them have a multiplicity of 2. So if both of them come down, touch that x-axis at the -1 and the 3. This one goes back up, and where does it go through? Oh, at 4.5. Okay, so let me label that. This will be 4.5, which is my, and I could do a little better on that one. There. And we'll say it hits right there, okay? All right, so there's my graph, and yeah, that's it. Moving on to the next one. 10, this one. Let's see, if I plug in 0 here and 0 here, I get 2 times 0 cubed minus 6 times 0 cubed, that's 0. All right, factoring though, if I set it equal to 0, what do I get? I can pull out a 2, I can pull out an x squared, which leaves me with x minus 2. All right, so let's see. Next, I got two things that equal 0. Either 2x squared equals 0 or x minus 2 equals 0. And if you solve those, you get x equals 0 or x equals 2. All right, so I got 0 and 2. And go make my graph. So this one has a multiplicity of 2. It's kind of good to write those down. It's easy to make that mistake. This one only has a multiplicity of 1 because there's only one x minus 2. All right, so make my quick graph over here. It's hitting 0, 0. It's also hitting 2. All right, and end behavior. Since it's 2x cubed, that is going to be down and up. Which means it goes down from here and up from there. And it does not hit, it hits the 0 but doesn't go through it, all right? But it goes through the 2. So I'm going through the 2. This one's not, I'm coming back down up. And there's approximately my graph, okay? All right. Next one. This one, oh, it's all factored out for me. I like those, x and y. 0, 0. So if I plug in 0, I get 1/4 0 squared times 1/4 times 0 squared minus 9. All right, so this is 0 times something, which is 0. So that one's definitely a 0. If I factor it, I got either 1/4 x squared equals 0 or x squared minus 9 equals 0. This one's going to be 0. I'll multiply by 4. I get x squared equals 0, therefore x equals 0. Multiplicity of 2 on that one. Add 9 over here. I get x squared equals 9. And therefore, when I take the square root, I get x equals plus or minus 3. Multiplicity of 2. This one's multiplicity of 1. Even though it's an x squared up here, you get the plus or minus 3, which gives you the two answers. I could also factor that, and gone x plus 3 times x minus 3 is your x squared minus 9, which would have given me the other two answers. All right, so let's look at end behavior. End behavior, 1/4 x to the 4th. If I multiply that out, which means positive and even, end behavior will be up and up. All right, so let me go graph this. Let's see, I got 3 of them, huh? 0, 3, negative 3. All right. Okay. And let's see, multiplicities. We said the 0 has a multiplicity of 2. End behavior is up and up. Let's start with the end behavior. Up and up. And then it's going through the 3 and the negative 3, but not through the 0. So it's going down here, and then it's going up and hitting that. So get this kind of, it's a lousy curve. Fix that. There, that's better. Okay. There we go. That's about what it looks like. So it hit the 0 with a multiplicity of 2, touched it, but didn't go through it, and went through the 3 and the negative 3, which had multiplicity of 1. All right, good. 12. All right, this one. If I plug in 0 here, I get 0 cubed plus 3 times 0 squared minus 4 times 0 minus 12. Oh, there's a minus 12. So it's the minus 12 is what you get when you plug in 0. Okay, and if I factor this, you can actually draw, this one's a good one for drawing a line down the middle and factoring. Okay, if I factor the left side and then factor the right side, because I looked at it and I said, gee, look at those factors. If I divide those by 4, I get 1 and 3. So that's a quick way to check whether this is a good technique. And there's an even number of them. So, all right, so if I pull out an x squared, I'm left with x plus 3. Over here, if I pull out a minus 4, I'm left with x plus 3, which means I got two sets of parentheses, x squared minus 4 in one of them, and x plus 3 in the other one. I'm setting those equal to 0, and I get x squared minus 4 equals 0, x plus 3 equals 0. So if I add 4, I get x squared equals 4, therefore x equals plus or minus 2. Over here I subtract 3 and I get x equals negative 3. Alright, so all of them have multiplicities of 1, except, yeah, all of them do. Okay, so I got 3 of them. I got 2, negative 2, and negative 3. And my end behavior is going to be down, up, because it's positive and the coefficient is positive, and x to the 3rd is odd. All right, so if I make my axes over here, I got a whole bunch of things to put through this one. All right, so negative 3, negative 2, 0. Actually, it doesn't hit 0 on the x-axis, it hits it on the y. Of course, I messed it up. Okay, so 0, negative 12 is down here. and the last one is at positive 2. All right, so it goes through all of them. And my end behavior we said was down, up. We start there. All right, so it goes through here and down here and back up there. Did I miss one? I feel like I missed one. Oh, I hit the x-axis or the y-axis at the wrong point. It's got to go all the way down to 12 and then go back up to 2. There we go. All right, so that's what my graph looks like. And there it was. So we got the last one here is a u-try. Once you try this one, do your x and your y, find the zeros. All right. And bring it into class. All right, and I think that's it. I was nice enough, I gave you a quick graph so you can check your work down there, show me what the zeros are, and how you got them, factor them as well. All right, and that's all I got for today. I'll close it out with a little bit of music. Have a great night.
Pick up all the pieces and make an island. But if it rains a little sand, goes all up with a child, No,